Good afternoon and welcome to the homework helper for 2.1. I just want to take a second and remind you guys to put your name on your packets. Put your last name too. We're being professional here. Period. Put 1 or 5, whatever works. And make sure you have your group seat. I'm going to call myself the Ace of Hearts today. All right. Let's go ahead and get started with what's going on for homework today. The very first part is this ready section in 2.1, where we're being asked to recognize arithmetic and geometric sequences. So we're being asked to predict the next two terms in the sequence and state whether the sequence is arithmetic, geometric, or neither. So what we can do to do that is look for the two things that we care about the most. The two things we care about the most, of course, let's zoom in a little bit on this note. And when I write things on a notepad like this, that's probably a good indicator of things that you should have in your personal notes, right? This is a post-it note. This should be in your binder somewhere so that you can study from. So there's a couple things I'm looking for when I'm looking for the next term in the sequence. For arithmetic, I'm looking for a common difference. Or a constant difference. And that means that I'm adding or subtracting by the same number at each step. And so one of the ways I can do that is I can look at two terms and evaluate whether or not there is a common difference. So when I look at 4 and negative 20 as two terms here, I can do negative 20 minus 4. Okay, negative 20 minus 4, and that gives me a negative 24. So what that tells me is that the difference between my n2 and my n1, right, because this is n1, this is n2, n3, n4, is a negative 24. So I went down 24 from n1 to n2. So for it to be a common difference, that must also be true of every step. So if I do n3 minus n2 here, so if I look at my n3, 100, and I subtract, in this case, a negative 20, it should equal negative 24 if it's arithmetic. And I do that, and I don't get that, I actually get a positive 120. I see I do not have a common difference. Therefore, this is not an arithmetic sequence. Therefore, I can't just add and subtract 24s to things and hope that it works out. So that's not going to work. But we'll leave this here just in case. The other thing that we care about is, of course, the geometric. And for geometric sequences, we're looking for a common ratio. That means we're multiplying or dividing by the same number each time. So to do this, it's very similar. You see how I took n2 and I subtracted n1? Well, here I'm going to take my n2 and I'm going to divide by my n1. And I'll see what my common rate or my ratio is, and then see if I have a common ratio. So I have negative 20, and I'm going to divide by 4. Well, negative 20 divided by 4 is going to be negative 5. So now, if I take my n3, my third term, and divide it by my second term, or this number divided by the number before it, if it's negative 5, I know I have a common ratio. So let's see, what's my n3? It's 100. And now I'm going to divide by the previous term, which is negative 20. And sure enough, that ends up being a negative 5. So I have a common ratio. What I multiply n1 by to get to n2 is the same as what I multiply n2 by to get to n3, and it's negative 5. So now that I know that I have a geometric sequence and that my common ratio is negative 5, I can just apply that to find the next two terms in my sequence. So if I'm trying to find the next term here, all I have to do is take negative 500, multiply that by a negative 5, so I know it's going to be a positive. What is that going to be? 2,500. And then I have to, is that right? 5 times 5 is 25. Yep, okay, good. I know what I'm doing. And now I have to take this and multiply it by a negative 5 to find my next term in the sequence. Let's just go ahead and do this on the calculator, save my brain a little bit of work. 2,500 times 5, but it's negative. So I'll just remember, where's that negative button? There you are. Boop. All right, hit enter. Wow, negative 12,500. Negative 12,500. And there we go. I have found the two terms I care about. Oop, there I wrote it. See? Evidence. All right. So that's true. That's neat. Let's go on to the next. And like if it didn't follow either of these sequences, if you did not end up with a common difference or a common ratio, we would then know that we have a neither sequence. But sometimes for those neither sequences, you can still figure out what the next steps are. Okay, let's move on to the next section, the set, where we're talking about discrete and continuous relationships. So the basic way to really kind of understand the differences between discrete and continuous, continuous. All right, discrete things are things that can be counted. So things that can be counted are like, days, people, etc. They can't be fractional. They can't be like you can't have, half of a person. Okay, I guess you could have half of a day, but we typically wouldn't say that. It's kind of like when we were talking about rounding. There's a certain age where you stop saying I'm 16 and a half years old. You just say I'm 16 or 17. So we kind of stopped doing that fractionally. Continuous are things that, while can be counted, they kind of blend together. So it blends. So things like the amount of water in a swimming pool. We're not counting the individual ounces because it's such a huge amount. It's too big. Now, when we're talking about time itself, this blends together, right? One moment, it's not like we jump a second ahead and we've missed like that whole part of a second. It blends together. It's continuously happening, as opposed to something like days, which is something that we count. 1, 2, 3, 4. Time will blend together. So it can be fractional, decimals. We can divide it infinitely, et cetera, et cetera. But let's look at this. Is this a discrete or continuous relationship? Okay, the hair on your head grows ½ an inch per month. So as it's growing, it's like, okay, so let's say, what's today, October 10th? October 10th, it is a certain length. On November 10th, does it suddenly just pop and it's a ½ an inch longer? No, it grows 1/30th of ½ an inch every single day, right? So this is a continuous relationship. Continuous. Your hair every single day gets a little bit longer, right? And so it's such a small amount that we don't notice from day to day to day to day. But when we look at a month's time, you're like, oh, my hair has really grown. Trust me, I don't have much hair. I pay attention to how much of it I have. So that's what makes it a continuous relationship, our hair. It grows slowly. It's not like just suddenly, boom, it's ½ an inch longer. Though that would be kind of cool. It's like those dolls that you would I don't know what they were called, but you would pull the hair out and you could cut it and whatever. I played with dolls. Get used to it. Okay, for every ton of paper that is recycled, 17 trees are saved. So is this going to be discrete or continuous? We have to look at the tree as a whole tree. Like when they are logging, they don't cut down half of a tree and leave half of it still in the woods, because we only needed half that tree that day. No, so we're going to view it as a full tree. So this is going to be discrete. Okay, and like let's say we recycled ½ a ton of paper, so we saved half of 17 trees. So it's 17 divided by 2. Well, that's going to be 8.5 trees. Do we save 8.5 trees? No, because that 0.5 tree still had to be cut down for the other 0.5 that was used in paper. So we only saved 8 trees. We did not save 8.5 trees. I hope that makes sense to you. Okay. Approximately 3.24 billion gallons of water flow over Niagara Falls daily. 3.24 billion gallons of water. again, when we're thinking about that degree of numbers, 3.24 billion, this is going to be continuous. It's not like at midnight 3.24 billion gallons are dumped. It's a little, well, it's not a little bit at a time, it's a lot of bit at a time, but it's happening continuously. Okay, the average person laughs 15 times per day. We can't really do a half laugh. So this is going to be a discrete relationship, discrete, right? I mean, I guess you could do a half laugh, like if you didn't really think it was funny, but you understand the point, et cetera, et cetera. So those are going to be our differences between discrete and continuous relationships. All right, let's move on to the final section, the go. All right, so we're solving one-step equations. We're going to find or use the unit rate of each of the questions below. Apples are on sale for the market, 4 pounds for $2. What is the price in cents of 1 pound? Okay, so if 4 pounds equals $2, if I divide by 4, I know that a pound costs 0.5, or as I would like to say, 50 cents. Because it asks for it in cents. Okay. 3 apples weigh about a pound. How much would 1 apple cost? Okay, so if I know it's 50 cents a pound, and I know that 3 apples is about how much would 1 apple cost? Okay, so 50 cents, so I got 3 apples is equal to a pound, but I know that a pound is 0.5, or in this case I'll say 50 cents. So I know that 3 apples is 50 cents. So if I divide by 3, I know that an apple is going to equal 50 divided by 3, 16.67 cents. So we will say 17 cents because we are going to round to the nearest cent. I've never given somebody 0.6666 cents in my life. So we would round that up to 17 cents. But basically that's what you have to do. You want to look at what's going on. Here's the key thing though. Look at 3 apples weigh about a pound. 3 times A equals P. And in here what we did is we just substituted the price of the pound, right? 4 pounds equals $2. So we knew that we were finding the price. 4 times the price of a pound is going to equal $2, and we figured out that was 50 cents. So make sure you're paying attention to your units and following all of that. When we scroll down a little bit to this section here, we see that we're just working with numbers. So we're just going to be dividing or multiplying as the case may be. Make sure you're using your calculator to check your work. All right, everybody. Good luck on all of this. I wish you well, and we will come back tomorrow and discuss it and all of that fun stuff. Have a good afternoon.